Welcome. If you're joining us on YouTube, this is the Denver Erlang and Elixir meetup for Monday, February 5th. My name's Michael Lubis. The meetup tonight is sponsored by Praxeal.io, which secures Elixir and Phoenix applications. If your business is using Elixir, please check it out. It's really cool. There's a GitHub app now. It stops data breaches, highly recommended. I also want to mention Codebeam America is coming up March 7th to 8th in San Francisco. The organizers were really awesome and gave me a discount code specifically for this meetup. So you get a discount on virtual and in-person tickets. It's Den Meetup. The URL is here. It's in chat too. I'm giving a training on Elixir security that's fully remote. Looks good.
Great. So first, I'll introduce myself because I didn't do an introduction earlier. I'm Thomas Millar. I live in Austin, Texas. I actually am very new to Elixir. I've only been doing it for like the better part of a year now. Originally, I come from the Python machine learning world, kind of hence why Instructor is one of my first open source projects in Elixir. And yeah, I've been doing machine learning and building data platforms at Stitch Fix for the last 10 years. And I've gone through many iterations of a data platform. And it was part of my research on how to solve some of the unique problems that you have when you're building machine learning applications. And really kind of the production operations of deploying them. When I was researching how to solve those problems, I came across Elixir, started to fall in love with it. And it's not quite there yet today, but I think it's poised to be a very strong stack to work on machine learning problems coming into the future. And personally, I'm investing. I'm all in on Elixir. So I'm glad to be here and meet y'all and hopefully chat more a little offline and later in the meetup about all that stuff. So anyways, that's enough about me. The motivation for this talk is really, we've been hearing a lot out in the industry that, AI is here, it's changing everything. We're only going to have a job for another 5 years. And everyone's raising tons and tons of money to build these kind of AI applications. And then you kind of use it and you see all the press releases of the new features and you're like, why is it always a chatbot? And how do we fix that? And really, why do we want to fix that? Well, so this is the kind of the central plot for this talk that I'm going to use to set up the framing of why we should care about this problem, and then how Instructor helps take a step forward to solving that. So with that, let's get started. So as I said, LLMs are kind of a powerful new technology, and you can either kind of dismiss it or be bought into the hype cycle. But there's like one thing that's really true about it is that it's this powerful thing that we've never had before. Whereas as developers, we're building these software systems, and usually we kind of structure all of our functions and the type specs and how they're calling each other to solve a problem on data structures. And that's how it's always been. No matter the language, no matter what, we write functions and we write functional or procedural code to solve problems. But LLMs are kind of a new technology where they're the oracle that can implement any function, right? And that's kind of fundamentally new, right? And so there is part of this AI hype cycle that is real. There is a new modality of compute here. It's like pixel data we haven't really been able to process before, and text data we really haven't been able to process before. And so whether you believe it or not, there's a digital god running in some data center somewhere that can solve, in theory, any problem. And this is its type specification. It's an LLM function. You give it a prompt as a string, and it returns an answer to your question as a string. And so you say, okay, great. Let's try to integrate this into our toolkit as developers. Well, in the domain of data types of our application, when we're dealing with strings, we really only have kind of two kinds of functions fundamentally when we're dealing with strings. we have our kind of toString functions, which take data structures from our application and turns them into string for presentational purposes or really many purposes. This is easy, right? This is string interpolation. This is template functions or templates. This is not hard. The other kind of function that we have is the inverse to this, which is parsing strings. And this is historically extremely difficult. Any tooling that we have to deal with this problem only actually works on a limited set of strings, right? Has to be the right format, otherwise you get a parsing error, right? You're dealing with formal language specs, regex parsers, any progress that we've made towards this problem historically has only been on a very limited input range of strings. But, when we can write them, we get data structures back, and all the logic in our application happens on data structures, not really directly on strings. So when we think of, okay, we have this new LLM function, and this is our toolkit with respect to the data types of strings, it kind of makes sense that this is what we have, right? We take the data of our application, we turn it into a prompt using a kind of toString function. We pipe that into an LLM, and boom, we have an answer to the theoretical question that we wanted it to solve. And it's the string. But remember, parsing strings is hard. So really, the only thing that we've historically been able to do when we come across this problem of unstructured string data, text data, is we delegate it to humans to be interpreted, right? A lot of us are web developers on the call. We take this unstructured data, we show it in a UI to the human to interpret, and they do some structured action through a Phoenix form, and we get the structured data from it. That's really the only other way that we've historically been able to do this. And so given that, the chatbot starts to make a lot of sense, right? Like this is the main loop of our function. And we create our kind of system prompt, data of our application toString, which kind of sets up what we want the LLM to respond to. And then our app loop is we put that into the LLM, then we get the answer out as a string. All we can do really is just pass it to the user to be interpreted. We get some data structure back from that form, and we loop. This is a chatbot, fundamentally. And so knowing these kind of a type theoretic, kind of abstract view of the technology, it starts to make a lot of sense, right? Why is everything a chatbot? It's because LLMs, they are incredible, right? I don't want to deny this, but they're completely inaccessible to traditional code, right? And this is a problem for us because most of the software that we write is integrating against systems that we don't have control over. We can't necessarily change. We can't renegotiate the parameter or the interaction with some APIs to put in a user to interpret, the LLM's response. We want to go from API to LLM back to API potentially, right? And so LLMs really are just completely backwards incompatible. And that's a problem for us because as developers, we want to build software systems, not necessarily just chatbots. You can build chatbots, they're great. Everyone's building them, awesome. But there's a whole set of things that we do as developers that's just like kind of off the table right now. And so with that as the framing, I want to spend the rest of the time, I want to introduce you to how we have been trying to solve this problem, the evolution over the last year and a half, and get to introducing you to OpenAI function calling, which is a main method that we use to solve this. And then I want to introduce Instructor, which is built on top of OpenAI function calling, which allows you to prompt these LLMs with Ecto, and why that's interesting. And then finally, I'm going to go over a bunch of examples of kind of how you can start using this. And really, it's because it's a new tool in our toolkit, we haven't really solved a lot of problems this way. And so it's not muscle memory. So I'm going to try to give you some heuristics that you can use when you're trying to solve problems to find out when you can use Instructor. Really, it's a pretty low level library. You can use it in a lot of different problems. So I'm going to help prime your mind to be a little more creative with this new technology. Okay, so with that, if these LLMs are so smart, then why can't we just ask them to respond in a format that we can parse, right? So parsing strings is hard. that's fine. It's smart. Ask it to respond. And so, I mean, that was the first, when the GPT API was released, that's kind of what we started trying to do. And it kind of worked, when you first asked it, you say, okay, I don't know, whatever the question, the response I got back from the LLM is in this case, a JSON payload. So username Thomas, sex is male. And say, oh, this is great. Well, I can parse this, JSON decode this, and like move on with my application. Then you come back tomorrow, and OpenAI released a new checkpoint of their model, and it's more fine-tuned for chat. And it says, now responds and says, sure thing. Here's some JSON, triple backtick JSON, whatever. Right? You say, oh crap. Well, now my integration code, I gotta, even if I could just very easily, try to pretend it's markdown parse, find the JSON block. You could imagine writing code to parse this. The JSON changed as well. Even if you solve that parsing issue, the JSON changed, right? In this first example, we have username Thomas, sex male, but it can output whatever it wants. So it says user Thomas and gender male. Semantically, the same meaning, but now the map that you get in your Elixir code is the keys are all wrong, right? So you're like, well, this is a problem. Parsing strings is hard, right? Like this is, we know this. And so OpenAI, that was about the first year of the API. And then OpenAI came out and they released something called function calling, and it's function calling to the rescue. We're going to change the type specification of the LLM now. So you take in a string and a JSON schema, and then OpenAI promises, with their best effort, to return a string that adheres to that JSON schema. So this is good, because this is not even solves just the JSON parsing, getting you to the JSON decode call, but it also ensures that the keys are correct, right? Because we define the JSON schema, and OpenAI is doing some magic behind the scenes, which I can get into later in the Q&A if anyone's interested how this works. And so this is good, this is better. We're not dealing with just like flaky code of string parsing. It's a little more structured. We take our data, turn it into a prompt, pass it to the LLM with some JSON schema that we get from somewhere. They're a little pain to write yourself, but whatever, at least we can get one. We get the string back, we JSON decode it, and then we can go into our app logic. This is good. This is huge progress. And you saw a boom of AI applications after they released this API. But it's not just, there's still the issue of like, okay, that's good, but it only really works for things that I can express in JSON. So like, it doesn't really work for dates or atoms or tuples or nested structures. I mean, the JSON schema can represent those things, but like the JSON.decode can't, right? And you say, wait a second. This problem looks familiar. Where else have we had to take string data or JSON data or some type of structured data and map it to complex data structures? Well, that's Ecto, right? Ecto change set takes our Phoenix forms and takes those, when you do an input type string or something, and you need to map it to a date, that's what Ecto cast does for us. And so this is the motivation. This is the kind of the realization behind Instructor, right? And Instructor isn't just in Elixir. I built an Elixir. It was actually my former roommate who originally built it in Python, and they use Pydantic, which is the equivalent of Ecto for Python. And there's a TypeScript version and a Ruby version in the works. And so what we're doing here is we're changing the LLM type spec one more time. We say, okay, we still have our prompt. But now, instead of providing a JSON schema, because those are a little tedious, let's provide an Ecto schema, because we already have those in our application. And then, instead of returning a string, let's return the exact Ecto schema, right? And so with this, you get a lot of benefits. It's not just about better JSON. With Ecto, you can get complex and custom types. We can start dealing with dates. You can deal with, I have an example where you can get the LLM to return a data frame. All of these things are easy. You can start pattern matching on these nested structures and the association and embeds, because it's not just it's your actual structs. It's not just maps and lists. And also, because it's Ecto, you get things like auto completion with your LSP, and you can leverage huge parts of the ecosystem because Instructor doesn't. It's not a wrapper of Ecto. It's just Ecto. And then most important part is that we can start dealing with validations. And let's get into what Instructor looks like, and this will kind of come back in a couple slides. So using Instructor is simple. We just define our Ecto schema as we're used to. So here we're, a struct for a politician. We says his first name and last name, their strings, what offices have the politician held, the office and from what to what date. Okay, so we're using complex data types, embeds, all the great stuff. And on top of this, you can also use a doc string, and Instructor will pass the doc string up to the LLM. So whereas the Ecto schema defines the structure of what we want, our doc string can provide the LLM the semantic meaning. Right? This doc string here is kind of your prompt to describe the semantic meaning of these fields. So we define our schema, and then we prompt the LLM. And so if you use the OpenAI client, this is the exact same schema. We just wrap it and we add one extra field, right? So that's the response model. So we say, who won the American 2020 election and what offices have they held? Right? And we say response model, politician. We know the answer we want is politician. You get the response, Joe Biden, and then the offices that he has held. So this is pretty good, right? But dealing with the LLM, it can start reasoning. Now we've solved this parsing problem where we get consistent keys, we don't get parse errors, these problems, but it doesn't mean the values that we get back in this struct are meaningful. And we're used to this, right? That's us working with our users using our Phoenix forms, right? They can input, we know we're getting the right structure that our code will integrate against it because we use Ecto, but the values might not be right. And we have change sets to solve this. We have validations. And so we provide an instructor, a use instructor validator kind of hook where you provide a callback, validate change set. And you can use all of the regular change set validations that you have in your code. If you have any custom ones, you can just reuse them here. It's just regular Ecto from this point forward. And so in this example, we're going to define, a series of numbers, and we're going to make sure that it has at least 10 items in the list and that their sum is even, whatever, just a kind of arbitrary example here. And then we prompt the model and we say, give us the first 5 integers. Now, obviously, that doesn't match the validations. And so we go and try to run it, and you get errors back, and it says the sum of the series must be even. You should have at least 10 items. And this is where the Ecto thing kind of becomes interesting again, because you start thinking, you say, okay, well, when I traditionally use Ecto, I'm using it for Phoenix forms. And when I have these errors, I don't know how to necessarily solve them, right? So I have to present them back to my user, and the errors must be in English or in the domain of, in the language that the user can reason it. But remember, our LLM can speak English, right? Speak any language. It can reason in the text domain. So we can kind of do something interesting here where we say, okay, we've been able to use software 1.0 to validate these things, make sure the data structure is even, whatever. But we can also use the LLM to validate the data. We can get a little recursive here. We can say, okay, we have a question and answer kind of example, and we want to make sure that this is going into a corporate environment. We cannot say anything objectionable. So you're building a chatbot for like a widget as a sale or a customer support widget for your website. So you do this and you say, okay, you got a question and answer. If we can go in here, we can say, what is the meaning of life? And if the answer comes back, sex, drugs, and rock and roll, we can say, no, validate with LLM. The answer cannot be objectionable. And we run this code, and we can see that the change set that comes back is not valid, and it says that the response is objectionable. So this is fine. We have our errors. We caught, potentially something that was bad. We got something that was bad, and we could, you could present that as an error in your application. But once again, the LLM can reason in the domain of language. So we have this error that our code generates. We can just turn around and ask the LLM to fix it, right? The change set errors are just strings. So we can just re-ask. You can just kind of turn around and say, okay, I originally asked you to, solve this problem. This is what you originally gave me. It's not good for these reasons. Fix it. Right? And so Instructor provides a second kind of convenience parameter here called max retries, where it will internally go through this loop up to, in this example, 10 times to try to fix its own errors in the semantic domain. And so when you run this code, you see a debug log, we pass the error back, the series must be even, it has 10 items, and then it automatically goes back and it says, GPT is like, oh, okay, no problem. Here's, 10 integers that are even. So this is very useful already at this point. And, we look at the problem space of LLMs, and we completely solved the parsing problem, right? With the help of OpenAI function calls and JSON schemas, that is no longer a problem. And then with Ecto, we provided us a really powerful tool set to get, structure out and start validating. We can't say we've necessarily fully solved this problem, but like we've given us good tools to build, just defensive code around this problem. But we did actually lose something, right? Remember, the original interface was string in, string out. And so in our chatbots that you see in these applications, you get this streaming functionality. And that's like super useful because a GPT-4 might take 60 seconds to respond. Most applications can't tolerate that kind of latency. And so the question is like, how do you stream parse JSON? I don't want to provide a library that makes some things better, but some things worse. I want to be better in all domains. And so I can't lose streaming. So Instructor, we solved this, but it's kind of it's kind of an interesting solution because you can't stream parse JSON. Are you going to get the closing bracket? But it turns out when you know what the shape of the JSON is supposed to be, you can make some assumptions in the parsing. So we implement our own stream JSON parser, and we provide two methods of getting stream parsing back. The first is called record streaming, and it's whenever you're using a top-level Ecto model. You can also, if you want to get a list, anything where the top level of the response is a list or an array, you can just change the response model to be an array of politician in this case, and we can ask for the first 5 presidents, and it will go and every time each kind of sub-object that last token has finished streaming in, we'll validate it and we'll admit it with a stream. So this is the code that we get here. So we're starting to get streaming back. The second form of streaming that we support is called partial streaming. So partial streaming is a little different. It says it's for top level, not arrays. It's just one kind of object. And what it will do is it will say, like, as each field kind of comes in recursively, we're going to start injecting and filling this thing out. And we'll emit for every chunk of text that we get, we'll start emitting these values. And then you'll get a kind of a final version that is validated at the end. So all the partial things aren't validated because, like, what does it mean to validate like an impartial struct? It doesn't make sense. And then you can validate it automatically validates it at the end. So I think I have a video here, but it never plays when I click on it. So this is kind of a little video demo in Livebook. I tweeted this out, but you can see this is what I mean by partial streaming. I know it's a little bit of a foreign concept, so a visual demo is a little easier to grok. So you can see it kind of just like fills things out. All right. So the other thing is that the motivation here is that this was all solved by OpenAI function calling. And while that is true, it doesn't mean that we're dependent on OpenAI. It turns out that we can get Instructor to work with not only OpenAI, but Llama CPP and hopefully Bumblebee coming soon, because the open source community has chased down and figured out how to implement function calling on the open source models as well. And so when you're thinking of this is kind of the feature set, this is kind of the domain. I think we've, Instructor has done a pretty good job of advancing the field uniformly in kind of all domains there without losing anything. And the way now when you're starting to think of how to use it, you should really start to think of Instructor as this interop layer between AI and regular software. And it uses Ecto as the interchange format. It provides full bidirectional interoperability. So when you're solving a problem, when I was writing this, I actually had this experience multiple times writing this, where I say, I'm starting to write a function and I realize I struggle with it. I go to bed and wake up the next morning. I'm like, oh, damn, I'm such an idiot. I could just ask the LLM to solve that for me. I don't have to implement. If there's a function that's kind of a tough implementation, maybe the LLM can solve it for you. Or another example of a heuristic that you can use to find applicability is just anywhere you have Ecto in your application, you can probably use Instructor. So in the documentation, I have some examples of how to use it. We have this little cookbook section where I provide kind of common things that people try to do: text classification, entity extraction, data generation, these sorts of things. The Python, I'm going to be filling this out with more examples implemented in Elixir using Instructor. But if you're looking for motivation for more examples, go over to the Python version of the library. They have way more examples in their documentation. So I'll be working on porting them over. Yeah, one of my favorite examples in that I've written so far is it takes a meeting transcript, from Zoom or whatever, and it will, let's say for it's a Scrum, morning Scrum or something like that, it will go and extract Jira tickets, the action items from the meeting, and who is assigned to what based on the transcript, and what tasks depend on other tasks based on the transcript, which is like a really kind of pretty sophisticated piece of software. You can automate, half the PM's job. So there's a fun example in there, but there's more stuff. RAG applications is the hot thing that you hear about on Twitter. Instructor's a great use case for this. So yeah, that's all I got. I want to kind of turn it back over, see if anyone has questions.